Namaskar. The topic of discussion in this module is on Aeolian landforms. Many geological processes are active on the surface of the earth. They are called as exogenous processes. These processes are capable of creating both constructional and destructional landforms. The agents which are responsible for these actions are called as geological agents. The notable surface geological processes are weathering, mass wasting, erosion, transportation and deposition. If any of these earth's processes are done by a natural system on the surface of the earth, then it is called as a geological agent. A geological agent is an earth's mass movement mechanism. There are so many cyclic processes involved in erosion, transportation and deposition of sediments on the surface. The notable geological agents that are capable of eroding, transporting and depositing the mass from one place to the other are running water, glaciers, wind, waves and currents and groundwater. These are also responsible for creating numerous landforms all over the world. The landforms created by the respective geological agents are also classified as fluvial landforms for streams, Aeolian landforms for winds, glacial landforms for glaciers, marine landforms for waves and currents, and karst topography for groundwater. Among all these, wind is a powerful geological agent. Wind is capable of eroding, transporting and depositing the surface materials. The word Aeolian is derived from the Greek word Aeolus, meaning the god of the winds. In this episode, the following aspects of Aeolian landforms are highlighted: wind and its action, geological processes of wind, erosional landforms, transportational effects and depositional landforms of wind. Let us see the first part, wind and its action. Circulation of air over the earth's surface makes the wind to blow. Wind has the ability and force to lift the earth's surface objects by any one of the mechanisms like deflation, abrasion, saltation and deposition. Deflation is the first mechanism. The blowing out and scattering of rock particles by wind is called as deflation. This term is originated from the Latin word deflare, means blow away. The surface of any desert is covered by diverse fragments of rocks, sands, soils and dust. These are arid zones. In such arid zones, streams and jets of air can blow out the sands and rock particles. First, the blowing wind clears the sandy and fine grained materials and leaves the coarser fragments behind. These form the rocky deserts. Such rocks are again weathered or fragmented, and then once again deflation becomes active. Deflation is the lifting and removal of fine dry particles of silt, soil and sand by the blowing action of wind. The effective force of a wind depends on its velocity. Even with little velocity, wind can lift most of the fine dust. Both stony and rocky deserts are formed due to deflation. The second mechanism is the abrasion. Abrasion is the mechanical scraping of a rock surface by friction between rocks and the moving particles during their transport by wind. It involves the process of corrosion. The particles transported by wind can strike the obstructing materials along its path. This forceful action of wind with such particles on rocks is called as corrosion. Corrosion can do grooving, scarring, polishing and grinding of the rocks. The intensity of corrosion depends on the size and density of carrying materials and also the earth's surface rocks. If the rocks are soft, the removal is rapid. The third mechanism is the saltation. Saltation is the intermittent leaping movement of particles of sand and gravel as from the force of the wind. It is an action of movement and transportation. It also includes rolling of materials along the surface. The fourth mechanism is deposition. Deposition is the geological process by which materials carried away by wind are settled down when the velocity gets declined. It also happens when there are obstructions. All these create new and new Aeolian landforms. The forces of wind that are responsible for all these mechanisms are of two kinds as driving and resisting forces. Winds adopt three important mechanisms for eroding the mass. They are lift, bombardment and drag. The lift results from combination of wind velocity and turbulence. There is a threshold velocity which is a function of particle size and cohesion, and also turbulence which changes in wind speed and direction. As turbulence increases, susceptibility of particles to lift increases. Bombardment is the collision of moving particles with stationary ones or with solid surfaces. It has abrasive action. In this process, there is also collision with the solid surfaces. Drag results from difference in force exerted on windward versus leeward side of particles, or difference in force exerted on top versus bottom of the particles. Drag also initiates sliding and rolling. It does not lift particles off the ground. The second part is the geological processes of wind. The power of wind to erode surface particles is controlled primarily by two factors. One is the wind velocity and the other one is the surface roughness. Erosive force increases exponentially with increasing wind velocity. For example, a velocity increase from 2 to 4 meters per second causes an 8-fold increase in the erosive capacity, while an increase in wind speed from 2 to 10 meters per second generates a 125-fold increase in its erosional force or power. Consequently, fast winds are capable of causing much more erosion than slow winds. At ground level, the roughness of the surface plays an important role in controlling the nature of wind erosion. Boulders, trees, buildings, shrubs and even small plants like grass and herbs can increase the frictional roughness of the surface and reduce the wind velocity. Vegetation can also reduce the erosional effects of wind by binding the soil particles to the roots of plants. Wind erodes the earth's surface by deflation, the turbulent eddy action, by abrasion and also by sand blasting of wind-borne particles. The regions which experience intense and substantial erosion are called as wind deflation zones. Most Aeolian deflation zones are composed of desert pavements. Almost half of the earth's desert surfaces are stony deflation zones. The rock mantle existing in desert pavements protect the underlying material from deflation. A dark shiny stain called desert varnish or rock varnish is often found on the surface of some desert rocks that have been exposed at the surface for a longer period of time. Manganese, iron oxides, hydroxides and clay minerals form most desert varnishes and provide the shine. Deflation basins called blowouts are also hollow surfaces formed by the removal of particles by wind. Blowouts are generally small but may be up to several kilometers in diameter. Wind driven grains abrade landforms. Grinding by particles carried in the wind creates grooves or small depressions. Ventifacts are rocks which have been cut and sometimes polished by the abrasive action of wind. sculpted landforms called yardangs are up to tens of meters high and kilometers long and are formed that have been streamlined by desert winds. The famous Great Sphinx of Giza in Egypt may be a modified yardang. In Aeolian processes, wind transports and deposits particles of sediments. Aeolian features form in areas where wind is the primary source of erosion. The particles deposited are of sand, silt and clay size. The particles are entrained in by one of the four processes. Creep is the first one. Creep occurs when a particle rolls or slides across the surface. Lift is the second mechanism. Lift occurs when a particle rises off the surface due to the Bernoulli effect. If the air flow is turbulent, large particles are transported by a process known as saltation. Finally, impact transport occurs in which one particle strikes another, causing the second particle to move out. The threshold velocity can be defined as the velocity required to entertain a particle of a particular size. In general, the larger the particle, the higher the threshold velocity required to move it. Silt is usually the easiest type of particle to be entertained by the wind. Silts can be easily transported and deposited by the wind with least velocity also. The next aspect is on erosional landforms developed by the wind. These are characteristic features of desert environments. Desert environments are characterized by a very low mean annual rainfall. The rainfall may be of less than 250 millimeters. They are also characterized by the absence of vegetation. Very high daily and annual range of temperature is yet another feature. Desert environments are characterized by severe dust storms and high velocity winds and the dominance of sand particles and sand materials on the surface. Winds are the most widespread geomorphic agents in these deserts, not only in the deserts but also in arid and semi-arid regions. Wind erosion generally takes place above the ground, and thus wind velocity plays a major role in determining the degree of Aeolian erosion. Wind erosion is effective only up to 180 centimeters above the ground surface. This is an important aspect in wind erosion. Maximum wind erosion occurs at short distances also. Unlike rivers and glaciers, winds erode the rocks from all sides because of their variable direction. River cannot erode in all sides, glaciers also cannot erode in all sides. Wind can erode in all directions because of their variable dimensions and directions. Deflation and transportation develop parallel with accumulation, giving rise to specific relief forms and types of Aeolian continental deposits and landforms. The erosional landforms of the wind are blowouts, deflation basins, desert pavements, desert varnish, ventifacts, mushroom rocks or pedestal rocks. Blowouts are important features of desert environments also. The most effective agents of abrasion are sand grains. Rocks that are exposed to the sand blasting of prevailing winds become pitted, grooved and polished. Deflation basins called blowouts are hollows formed by the removal of particles by wind. Sand grains are rolled and skipped along the surface and comprise the bed load. In such a way, the entire bed is lowered, in some cases up to 1 meter, resulting in shallow depressions called blowouts. Blowouts are depressions which may be a few meters to a kilometer across. This depression may be a few meters to as much as a kilometer across. Blowouts are also found on the rock surfaces which are subjected to disintegration by further weathering. Deflation basins are depressions formed in the deserts due to the removal of sands to a greater extent. The size of the depressions vary from small wallows to big hollow deeps. A desert pavement is a typical desert surface. It is covered with closely packed interlocking angular or rounded rock fragments of pebble and cobble size formed by the gradual removal of the sand, dust and other fine grained materials by the wind and also the intermittent rain. Stone or desert pavements are larger stones set in or in a matrix of fine grained materials. Desert pavements are only 1 or 2 fragments thick that form a mosaic in a matrix of fine sediments. Coarse fragments are alluvial pebbles, gravel and cobbles or debris weathered from the bedrocks. Desert pavements cover areas ranging a few square meters to hundreds of square kilometers. They occur mostly in sand poor regions. Next comes the desert varnish. Desert varnish is a dark coating on the rocks found in arid regions composed dominantly of fine grained clay minerals containing black manganese oxide and red iron oxide. Varnish can be a prominent feature in many landscapes. It often coats canyon walls also. Earlier it was believed as varnish was made from substances drawn from the rocks its coat. Microscopic and other observations show that a major part of varnish is clay which could only arrive by wind. Clay acts as a substrate to catch additional substances that chemically react together when the rock reaches high temperature in the desert sun. Wetting by dew is also an important activity in this process. Desert varnish has a high concentration of manganese, 50 to 60 times more abundant than elsewhere. Black manganese oxide and red iron oxide add the color to desert varnish. Desert varnish forms only on physically stable rock surfaces that are no longer subject to frequent precipitation, fracturing or sand blasting. Desert varnish often obscures the identity of the underlying rock, and different rocks have varying abilities to accept and retain this desert varnish. Limestones, for example, typically do not have varnish because they are too water soluble and therefore do not provide a stable surface for varnish to form. Shiny, dense and black varnishes form on basalt, fine quartzites and metamorphosed shales due to these rocks relatively high resistant for weathering. Ventifacts are important features. Ventifacts are stones faceted by abrasion. With changing direction of dominant winds, different facets merge along sharp ridges to form rounded stones to angular ventifacts. The facets can be worn into the face of a rock oriented into the prevailing wind direction. Next comes yardangs. Yardangs are wind abraded ridges oriented with the prevailing winds and separated by abraded chutes of wind blown sands. Yardangs are larger hill sized features sculpted by the wind. Yardangs are composed of cohesive sills and clays, sandstone or limestone. They develop in regions with strong unidirectional winds. Many of them are formed during dry wind periods of Pleistocene period. Yardangs are classified on the basis of size as mega yardangs, meso yardangs and micro yardangs. Mega yardangs can be of several kilometers long and hundreds of meters high. A large concentration of mega yardangs is found near the Tibesti mountains in the central Sahara. Meso yardangs are generally a few meters high and 10 to 15 meters long. These are more common and can be found throughout the Sahara. Micro yardangs are only a few centimeters high. Next comes the mushroom rocks. Mushroom rocks are the exposures having broad upper part and narrow base carved by the action of wind over an existing standing rock mass. The pedestal rocks are called as gara in Sahara. Undercutting is a marked feature of wind abrasion. It is almost effective within 30 to 60 centimeters of the surface where saltation of sand is abundant. Rocks formed by undercutting are known as pedestal rocks. Oasis is an important feature in the desert regions. In geography, an oasis is an isolated area of vegetation in a desert typically surrounding a spring or similar water source. Oases also provide habitat for animals and even humans if the area is big enough. The location of oases has been of critical importance for trade and transportation routes in desert areas. Oases are very important features in the Aeolian landforms. The fourth important aspect is related to transportational effects. Particles are transported by winds through suspension, saltation and creeping along the ground. Small particles may be held in the atmosphere in suspension. Upward currents of air support the weight of the suspended particles and hold them indefinitely in the surrounding air. Typical winds near Earth's surface suspend particles of less than 0.2 millimeters in diameter and scatter them aloft as dust or haze. Aeolian sediment transport happens in the following three ways. One is the suspension, the second one is the saltation, and the third one is the creep. Suspension is a process in which the air suspends particles less than 0.2 millimeter in diameter. This dust is carried thousands of meters upward and thousands of kilometers downwind, held in suspension by turbulent eddies. Saltation is the transport of sand grains in long trajectories as the momentum is passed from grain to grain. Most of the transport of dune sands happens through saltation. At high wind speeds, saltation is more or less continuous. Saltation is the downward movement of particles in a series of jumps or skips. Saltation normally lifts sand-sized particles not more than 1 centimeter above the ground and proceeds at 1/2 to 1/3 speed of the wind. A saltating grain may hit other grains that jump up to continue the saltation. The grain may also hit larger grains that are too heavy to hop, but that slowly creep forward as they are pushed by saltating grains. Surface creep accounts for as much as 25% of grain movement in a desert. Creep is a movement of coarse sand and pebbles as they slide and roll, impacting one another and transferring the momentum. It usually does not occur with velocities less than 4.5 meters per second. Air over deserts is cooled significantly when rain passes through it. This cooler and denser air sinks towards this desert surface. When it reaches the ground, the air is deflected forward and sweeps up surface debris in its turbulence as a dust storm. At wind velocities of up to 6.5 meters per second, dust and fine sands of 0.25 millimeters diameter are carried away. At 10 meters per second, the wind can lift and transport particles of 1 millimeter in diameter. At 20 meters per second speed, particles of 4 to 5 millimeters diameter are transported by the wind. Hurricanes can carry even small stones from one place to the other and hit the houses, buildings and other structures very effectively. These are all the features which we are seeing in the news regularly. The dust of African deserts is transported by strong trade winds over distances of 2000 kilometers to 2500 kilometers. Sometimes the dust and particles may obscure the sunlight also in these regions. The fifth important aspect are the depositional landforms of wind. Sandy Aeolian deposits are distinguished from other continental deposits by a number of specific features. They are irregular cross-bedding, gentle dipping, steep and orienting in different directions. Aeolian deposits are relatively small in size. The particles may range from 0.05 to 0.25 millimeters in diameter. Dust particles are almost completely absent at the location of deposition. The grains of Aeolian sands are generally well rounded due to prolonged transportation by wind. Sometimes they are well polished also. The depositional landforms of wind are ripples, sand dunes, ergs, sand sheets, sand shadows, loess and takirs. Ripples are small sand waves created with a wavelength of about 1 meter, that is the typical path length of saltating grains. They are ephemeral and mobile, that is they move, disappear and reform during wind storms. These are common in the windward slopes of sand dunes. Dunes are classic Aeolian landforms. They are stable or advancing landforms of wind-blown sands. They originate as a mound of free sand from a sandy superficial deposit or from a blowout. As the mound grows, it develops the dune asymmetry characterized by a gentle windward slope and a leeward slip face at the angle of repose of sand. Dunes are much less mobile. They migrate downward as sand saltates up the windward face. Dunes are further classified into the following types: Birchen dunes, parabolic dunes, transverse sand dunes and longitudinal sand dunes. Birchen dunes are classic asymmetric crescent shaped desert dunes. Birchens are isolated sand dunes. They freely migrate across the desert plains, maintaining their forms. Their characteristic feature is their wings. They have a long and gentle windward slope and short and steep leeward slope. Birchens range in height from 2 to 15 meters. Occasionally, they rise a height of 20 to 30 meters. Their width may also go up to 140 meters. Parabolic dunes are associated with vegetation. They are formed in subhumid and semi-arid environments rather than arid zones. They initially originate as a blowout and the dune forms as the head of the dune at the downwind edge of the blowout. Transverse dunes are linear, cuspate, ridgy sands formed perpendicular to the wind direction with large sand supply and low winds. With stronger winds, they may evolve into birchens. They usually occur on beaches, floodplain alluviums or erodible sandy bedrocks rather than the dry deserts. Longitudinal dunes are linear forms parallel to the strong persistent winds. They are called as sheaves. They form in dry subtropical deserts with irregular sand supply. They are also separated by a lag gravel. Whalebacks are ridges of coarse sand left in the path of a migrating longitudinal dune. Yergs are sand seas. They are very vast sand sheets. They cover about 1/4 or 1/3 of the area of the true deserts. These sandy deserts overlay the poorly consolidated sandy bedrocks. Next comes sand sheets. Sand sheets are flat, gently undulating sandy plots of sand surface by grains that may be too large for saltation. The surface is usually rippled. Pits generally display layers of two distinct grain sizes. This is due to the fact that larger grains are transported by creep while smaller ones are transported by saltation. Sand sheets are formed on borders of deserts having scanty vegetation. The fixed sand sheets are undulating sandy hills in subhumid environments. The Selima sand sheet, which occupies 60,000 square kilometers in the southern Egypt and northern Sudan, is one of the earth's largest sand sheets. Sand shadows are the accumulation of sand on either side of a fixed obstacle. The obstacle may come from a shrub or a tuft of a grass. Sand drifts are accumulation of sand in the lee of a gap between obstacles or in the still air at the base of an escarpment. The next important feature of Aeolian landform is the loess. Most of the dust carried by dust storms is in the form of silt size particles. The deposits of this wind blown silt are known as loess. Loess is a homogeneous, typically non-stratified, porous, friable, slightly coherent, often calcareous, fine grained, silty, pale yellow or puff colored wind blown sediments. Loess generally occurs as a widespread blanket deposit that covers areas of hundreds of square kilometers and tens of meter thickness in deserts and other places. Loess tends to develop into highly rich soils. Loess deposits are geologically unstable by nature and will erode very rapidly and also easily. Takirs are yet another formations. Takirs are flat, smooth, clayey deserts ranging in size from a few square meters to several square kilometers. They develop as a separate basin. A takir is usually formed in a shallow depressed area with a heavy clay soil which is submerged by water after seasonal rainfall. After the water evaporation, a dried crust with fissures forms on the surface of the takirs. You might have seen in many places the crisscross pattern of cracks formed in the takirs. Wind is a major geological agent. It changes the landscapes of arid and semi-arid regions with new landforms. It is a highly dynamic system forming unstable landforms. Wind created landforms are subjected to wind action again and again. Understanding of their movements and deposition is a basic requirement in earth sciences.